So, hello everyone, I am APURVA GADEKAR from Central University of Tamil Nadu, registration number P242008. Today I am going to explain you about the wastewater treatment systems like primary, secondary and tertiary wastewater systems. So, what is the wastewater system? Like comprehensive, it is the comprehensive analysis of primary, secondary and tertiary treatment processes for suitable environments management and public health protection. So there is, we can say, there is the two parts of this video. So this is the part B, and in part A there is the introduction and primary wastewater treatment is explained well in part A. So this is part B. I am going to explain here the secondary wastewater treatment and tertiary wastewater treatment. So uh, let's see the slides. So this all are content of my PPT. So introduction and overview, primary treatment systems, secondary biological processes and tertiary advanced technologies. So introduction, overview and primary treatment systems is there in part A of the video. So I am not explaining that. I am explaining here the secondary biological processes and tertiary advanced technologies. So this is the wastewater treatment fundamentals. This came in introduction. So wastewater characteristics and compositions, wastewater treatment processes overview, primary treatment technologies, primary treatment performance metrics, primary treatments equipments and components. And from here I'll start explaining from here, because that previous all slides which I skipped is actually the introduction, overview and the primary wastewater treatments. So from here we can say like secondary treatment, biological processes. So in that biological treatment principles, so what is the principle of biological treatments? Like secondary biological treatment, it is the harnesses naturally occurring microorganisms to recompose organic pollutants through aerobic and anaerobic conditions. This sophisticated system maintain optimal temperature, optimal pH, optimal biochemical oxygen demand rate, and it help to clean the water and make the water potable. Like in using the microorganisms which are aerobic and anaerobic in condition, it minimizes the operational cost of the treatment. So here is the aerobic decomposition processes and anaerobic digestion systems. In aerobic decomposition processes, here is the oxygen rich environment support bacterial growth, consuming organic matter while producing carbon dioxide and water. They are they are consuming organic matters and releasing out the carbon dioxide in water. And anaerobic digestion system, here is we are providing the oxygen free conditions. It enables the methane producing bacteria to break down organic compounds while generating biogas for energy recovery applications. In secondary treatment methods, there is the four methods we can say: activated sludge process, constructed wetland system, trickling filter system and rotating biological contractors. So in activated sludge processes, it suspend the growth system, utilize mixed liquor of microorganisms, achieving 85 to 95% BOD removal through controlled aeration settling. With the help of some aeration settling, we are achieving 85 to 95% biochemical oxygen demand removal. In constructed wetland system, it like what is the wetland? So after that, wetland is it mimics the natural wetland system which help to clean the water naturally. So it is the natural treatment using plants and microorganisms in engineered wetland, like engineered artificial we can say, it providing the cost effective treatments with minimal maintenance requirements. After that, trickling filter system, it fixes the film bioreactor using rotating distributor. They are using the rotating distributor in prickling filter system, and in rotating biological contractor they are using partially submerged rotating disc. Like not that much big difference, they are same only. They are rotating the distributors, rotating distributors and submerged rotating disc. They are doing the same work to dissolve the oxygen. And after that, the secondary treatment performance analysis. 90% of BOD removal is happening here. 85% TSS reduction, 99% pathogen elimination, and 75% sludge recovery is there. So in process control we are just maintaining the temperature, oxygen and pH in the controlled manner to like more productiveness of microorganisms. In operational parameters we are maintain mixed liquor suspended solids at optimal concentration, control sludge age balancing efficiency with operational cost. And in performance monitoring we are monitoring at real time, like how much oxygen measurement prevent process upsets, and automated nutrient dosage maintaining, and effluent quality analyzers. So in biological treatment systems, these are some like in pie chart we can say this is, there is some like some technical issue that label doesn't come here, but I'll explain you I'll explain you. This is the biological treatment system comparison uh, in biological treatment system, that which biological treatment is uh, doing in a high amount, like how a high amount, and which is going on in low amount. So uh, that the most like 450 portion, like greenish portion is activated sludge process is going this much of thing. And trickling filters are giving in 280, and rotating contractors in 180, sequence batch reactors in 120, and membrane bioreactors working in 90% we can say. So after that, advanced tertiary treatment technologies. So in advanced tertiary treatment technologies, membrane filtration processes is there, and advanced oxygen systems is there. So in membrane filtration processes, their ultrafiltration and reverse osmosis membrane removes dissolved contaminations, pathogens, and trace organic compounds, achieving water quality suitable and potable for reuse applications. So we all know that all our water filtration systems came with the ultrafiltration and reverse osmosis system. So we all are familiar with the RO system. And in advanced oxidation system we are using the ultraviolet light combined with the hydrogen peroxide or oxygen create powerful hydroxyl radicals capable for destroying persistent organic pollutants and emerging contaminants. We are using here the ultraviolet rays to destruct the organic pollutants, like we are destructing them with the ultraviolet light and hydrogen peroxide. So here the in tertiary treatment application and benefits, water reclamation objectives. Here is then nutrient removal system, pathogen inactivation methods, and trace contaminant removal. In nutrient removal system, biological and chemical phosphorus removal, like we can say we know eutrophication, that is the like excess amount of phosphate and nitrogen in any kind of water bodies, it leads to the eutrophication, and finally it leads to algal bloom. So this is only the nutrient removal system. After that, pathogen inactivation method, we are using chlorination and UV disinfection. We are using here the disinfections methods to to clean the water, like and after that trace contaminant removal. Advanced treatments removes emerging contaminant including pharmaceutical and personal care. In trace contaminant removal, we are using some advanced treatments. After that, this tertiary treatment performs analysis. This is the bar graph. Again you can see what is the outcome of this. So tertiary treatment achieves the exponential pollutant removal rate exceeding regulatory requirements for direct discharge and water reuse application. Advanced processes removes over 95% of the remaining contamination while providing pathogen elimination rate 99.99%. Like uh, with this uh, treatment method, wastewater treatment methods, we can say it removes 95% of contaminants and 99% of pathogens. So this are just the outcome of the this bar graph. After that, some emerging technologies and innovations. So smart treatment system, like in this AI powered processes we can use for reduce the energy and machine learning algorithms optimal chemical closing in process parameters automatically. For automatic use we can for automatic system we can use the machine learning algorithms. And for energy consumption, like reduce in energy consumption, we can use the AI powered processes. In membrane bioreactor technologies, we combine the biological treatments with membrane filtration in single process. Like we are doing this presently, we are combining these two processes in single method. So these are the membrane bioreactor technology for effluent treatment. You can see membrane bioreactor processes. So grid solid removal, everything is there. This is the resource recovery and sustainability circular economy. And we can say 85% resource recovery rate is there in sustainability. It recovers the phosphorus, and advanced treatment generates high quality reclaimed water supporting suitable development goals and circular economy principles. 85% resource recovery rate is there. This is the global treatment standard comparison. Urban, like WHO reuse guidelines, advanced treatments, potable reuse, US secondary standards, Europe urban directives. And after that, this like we can say biological oxygen demand, solid suspension, total nitrogen, total phosphate, 76% global treatment coverage. Like globally it covering the 76% and 60% safe treatment rates. After that, future challenges and opportunities. Climate change and adaptation. Climate change is the big challenge to the wastewater treatment plants, because rising in temperature leads to microorganisms. They slow the metabolic pathway, and they are reducing the every process they are doing previously. And in low temperature also they are not they are not working properly. In emerging contaminants management, pharmaceutical residue, microplastic, and pre and polyfluoroalkyl substances require innovation treatment technologies including advanced oxidation membrane processes and specialized adsorbent to address this persistent pollutant effectively while protecting public health and environmental quality. Then energy neutral operations is there. Sustainable treatment facilities target zero energy consumption and all. Renewable energy we can say. So this is just the quote. Suitable, like, sustainable wastewater treatment represent the convergence of en- environmental stewardship. This comprehensive analysis demonstrate the critical importance of multi-stage treatment processes in achieving sustainable water management goals with addressing emerging environmental challenges and resources recovery opportunity. So these are the advanced treatment processes flow diagram which I explained previously. You can refer. These are my references, and thank you so much for your attention. Thank you so much.